So today I am going to solve another example. Okay, this is a Murray network. Murray network, the output depends on the present state. Okay, so not on the external inputs. In yesterday's class I had solved with using D flip flop. In D flip flop the characteristic equation is same, Q plus is equal to D. So excitation and transition table were same in the yesterday's class. In today's class what I am going to try to tell you that for JK the characteristic equation is different. Okay, so here we have JK, this is a JK flip flop and this is another JK flip flop. So first what you have to do, looking at this, one thing is what type of question may be asked on this. Construct a excitation table, transition table, state table and state diagram for the following logic network. It may be, the logic network may be of Mealy type or of Murray type. In yesterday's class I have taught you about Mealy type. In today's class I am going to talk about Murray network. Okay. So for this, how do we write? First we need to write the excitation and output expressions. So for this, how do we write the excitation and the output expressions? Okay. So J1 equal to Y. Here J1 equal to Y. Next, what is K1 equal to? K1 equal to, see here, Y plus, here this Y plus X, and one more input is coming from Q2 bar. So X into Q2 bar. Next, J2 equal to what? In the similar way, J2 is equal to X Q1 bar. This is Q1 bar, this line. X Q1 bar plus what you have here in the next three inputs are there, X bar Y and Q1. It is coming from Q1. The third input is coming from Q1. Okay, so Q1. Next, K2. So for K2, how do you write? K2 equal to, see here we have XY bar plus here XY bar, XY bar, okay, plus XY bar plus Y into Q1, YQ1, okay, so YQ1. Next, one of you unmute and tell me what is Z1 equal to? Can you tell me what is Z1 equal to? One input is Q1, another input is Q2 bar, isn't it? What is Z1 is equal to? Q1 and Q2 bar. Next, what is Z2 equal to? Z2 equal to what? Q1 plus, this is the OR gate, isn't it? Q1 plus Q2 bar. Q1 plus Q2 bar, isn't it? So in this way you have to write the excitation and output expressions. So given a logic network like this, construct a excitation table, transition table, state table and state diagram for this. So this is a particular 10 to 12 marks question. Okay, so here first you have to write J1, K1, J2, K2 and then Z1, Z2. These are excitation expressions and Z1 or Z2 are the output expressions. Okay. Next, so here excitation and output expression for the second example I have written here. The same thing I have written here. In the previous slide with the pen I had written the same thing I have written here. The same excitation and output expressions for the logic network given. Okay. So here now you need to tell me what is the characteristic equation for JK flip flop. See, in the example we have used two JK flip flops. So here Q1 plus is equal to J1 Q1 bar plus K1 bar Q1. Okay, this is a characteristic equation. What is this? Characteristic equation of JK flip-flop. Characteristic equation of a JK flip-flop. Okay, so Q1 plus is equal to J1 Q1 bar plus K1 bar Q1. Next, Q2 plus is equal to J2 Q2 bar plus K2 bar into Q2. So here J2 into Q2 bar plus K2 bar into Q2. So what is this, students? This is the characteristic equation of the JK flip-flop. Now next what you have to do here is, here you have Q1 plus in equations you have, no? So you have equations like J1 equal to what, K1 equal to what. You have to substitute J1 and K1. See here, we have substituted here. See, J1 equal to Y, no? Y into Q1 bar plus K1 is equal to what? Y plus X Q2 bar. K1 bar, no? So we have taken bar of it into Q1. Simplify this, you will get the expression. So Q1 plus is equal to, the expression is written here. This is a Q1 plus expression. Next, Q2 plus expression in J2. What you got? J2 equal to, J2 equal to X Q1 bar plus X bar Y Q1 into Q2 bar plus K2. Okay, what you got? K2 expression. K2 you got XY bar plus YQ1 bar you have into Q2. Simplify this, you will get this expression. Okay, so what did you do in this slide? In this slide, the excitation expressions of J1, K1 is substituted into this. J1 equal to Y, you wrote this. K1 equal to, what is the expression you have written here? Take a bar of it into Q1. Simplify this expression, you will get this expression Q1 plus. Next, Q2 plus is equal to X. That is J2, you have to substitute J2 here into Q2 bar plus K2. Substitute K2 here, take the bar of it into Q2. So what you have to do here? You have to substitute J1 and K1 in Q1 plus and substitute J2 and K2 in Q2 plus. Simplify it and get the expression. Simplify and get the reduced expression. Okay. So expression for what? Expression for Q1 plus and Q2 plus. So this is the next step. What are these? These are transition equations. Okay. What are these? Transition equations. What did you do first step? First step you wrote the excitation and output expression. Okay. After writing that, next what did you do? You wrote the Q1 plus and Q2 plus. Okay. So you wrote the characteristic equation. After writing the characteristic equation of the JK flip-flop, you have substituted J1, K1, reduced it, simplified it and got the expression, this one. Next, for Q2 plus, this is the characteristic equation. In this, we have to substitute J2 and K2, simplify it, reduce it and get the expression. So these are the transition equations. So this is the next step, transition equations. In the earlier problem, yesterday's class, Q1 plus was equal to D. So you had Q1 plus and D same. So the transition table and the excitation table was same for the yesterday's problem, which we solved using 7.1, that is using D flip-flop. But in this case, because the characteristic equation is different for JK flip-flop, so it will be different. So you need to substitute J1, K1, J2, K2 in Q1 plus and Q2 plus and reduce it and then get the simplified expressions. Okay, next step. So here you need to write the transition table. Okay, how do you write transition table now? See here, present state is q1 q2, so write directly 0 0 0 1 1 0 1 1. Next table is next state, so write q1 plus q2 plus. Inputs are two here, x and y, so xy can be 0 0, can be 0 1, can be 1 0, can be 1 1, isn't it? So here how to construct this, how to do this now? Input is 0 0, okay, and q1 q2 is 0 0. So substitute in q1 plus expression, q1 plus. So what is q1 plus is equal to, q1 plus is equal to y q1 bar plus x bar y q1, okay, x bar y q1 plus y bar q1 q2. Now you need to substitute in place of xy 0 0, next in place of q1 q2 0 0, and tell me the value. What is the answer for the first one? Okay, so here this is q1 plus, here this is q2 plus. Okay, this is q1 plus, this is q2 plus, this is q1 plus q2 plus, q1 plus q2 plus. So first always you try to do with the q1 plus here, the first one. So what you got the value when you substitute xy 0 0, okay, and q1 q2 0 0? I think you got 0. Yes. So here what are these values? These values are q1 plus, q2 plus, sorry, okay, so this is q1 plus again. Okay, first column is q1 plus, the first column is q1 plus, next column is q2 plus, the next column is q2 plus, the next column answers are q2 plus, the next column answers are q2 plus. So the first column, the very first column is q1 plus, as usual, first column q1 plus, next column q2 plus. So how do you get these values? These values are got by substituting xy 0 0 in the first and q1 0 0. You will get 0. Next value, how did you get this 0? Substitute xy 0 0, q1 q2 0 1 in the q1 plus expression. You will get this value. Next, how did you get this 1? Substitute xy 0 0, q1 q2 1 and 0. You will get 1. Next, how did you get this 1? Substitute xy 0 0 and q1 q2 1 1. You will get 1. Substitute in the q1 plus expression. Okay. Similarly, inputs will change now. 0 1 xy and present state is 0 0. You will get this. So similarly, you have to fill all the q1 plus columns. Next, what is q2 plus expression? q2 plus expression is x q1 bar q2 bar plus x bar y q1 q2 bar plus x bar y bar q2 plus x bar q1 bar q2 plus y q1 bar q2. Okay, so one of you unmute and tell me, if I substitute x is equal to 0, y is equal to 0, q1 is equal to 0, q2 equal to 0, what is the answer? What is the answer? You will get you should get 0. What is the answer you got? Tejas, can you tell me? So transition table consists of 3 sections: present state, next state, output. Okay, so where inputs will change, present state will change. Just substitute the input and the present state values and get these values in the next state. Next, third section is the output Z1 and Z2. Z1 is Q1, Q2 bar. Just substitute the Q1, Q2 values. You will get the Z1 values. Next, Z2 is equal to Q1 plus Q2 bar. Just substitute the Q1, Q2 values. You will get the Z2 values. So this is about the transition table. Okay. So next, about the excitation table. So excitation table. So this excitation table, how to do this? You know, no, this excitation expressions you have. What are the excitation expressions? J1 equal to what? Y. Next, K1 equal to what? Y plus X Q2 bar. Next, J2 equal to X Q1 bar plus X bar Y Q1. Next, K2 equal to X Y bar plus Y Q1. Okay. So now here excitation table have three sections again: present state, excitation, output. So present state 0 0 0 1 1 0 1 1, you write it. Next, excitation expressions are 4: J1, K1, J2, K2. Inputs are 2, X and Y. So it varies 0 0 0 1 1 0 1 1. So this is J1, K1, J2, K2. Next, J1, K1, J2, K2. Next, J1, K1, J2, K2. Next, this is also J1, K1, J2 and K2. So these are 4 columns, isn't it? Why? Because J1, K1, J2, K2. You have 4 excitation expressions. So again, what you have to do here is input values will change: 0 0 0 1 1 0 1 1. Present state values will change: 0 0 0 1 1 0 and 1 1. Okay. So J1 equal to Y, right? J1 equal to Y. So first Y value, what it is? Just write it: 0 0 0 0 0. Y value is what here? J1 equal to Y, so 0 0 0 0, right? K1 equal to Y plus X Q bar, Q2 bar. Substitute now. Y is equal to what? 0. Okay. And next, X is equal to 0. Q2 bar. So you have to Q2 bar and 0 bar. So it is 1. So what you will get again? Answer 0 only you will get. Next, K2. K2 is equal to X is 0, Y is a 0 plus Y is 0 again, Q1 is 0. So substitute K2 value, then write it. Okay. So just what you have to do, use these J1, K1, J2, K2 expressions, change the value inputs X, Y, and then change the values Q1, Q2, substitute these X, Y and Q1, Q2 values inside these excitation expressions, and then get the value. You can just write like this: J1, 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 first column, finish it off J1, all the values. Next, J2, J2, J2 and J2, finish it off. Next, okay, K1, sorry, K1, this is J1, next K1, next J2, next K2. In this order it is. Okay. So J1, K1, J2, K2. So substitute the input values and the present state values and get the values inside this and write it. Z1, Z2 output same as in the transition table we have done, no? Same thing you have to write here. So students, so next is, so we have studied about the excitation table now. So next we have constructed transition table from the excitation table, that is the output we have taken same as it is. Consider, okay, the one example they have shown here. Okay. Next, state table. State table consists of 3 sections: present state, next state, output. Actual binary codes are used to represent the state, and that is not important. Alphanumerical symbols can be assigned to represent these. That means for the state 0 0, I will assign state A. For 0 1, wherever 0 1 comes, assign state B. Wherever 1 0 comes, assign alphanumerical symbols. What is this? Alphanumerical symbols. 1 1, I will assign it D. Okay. So here, so state table is essentially a relabeling of the transition table. So you should have the transition table. So in the transition table you had, so here we are, for the transition table we are putting this A, B, C, D, for that is 0, 0, 0, 1, 1, 0, 1, 1, we are assigning it. Okay. So this is for the state, the JK flip flop. So for 0, 0 we are assigning A, 0, 1, B, 1, 0, C, 1, 1, D. Okay. So wherever it is for the transition table, wherever the 0, 0 comes, here it is 0, 0. So it is A. Okay. So next it is 0, 1, if it is B. Next it is 1, 0. So it is D. Okay. So I'll just put the values. Okay. Values I am going to put transition table. 0, 0, here it is 1, 0, 1, 1, 0, 1, 1. Next it is 1, 0 here, next 1, 1, 0, 1, 0, 0. Next here it is 0, 1, 0, 0, 0, 0, 1, 0. Next value is 1, 1, 1, 1, 0, 0, 0, 0. So how did I get this state table? First it is nothing but relabeling of the states by binary symbols. Okay. So state table is done through the use of a transition table. With the help of the transition table, state table is written with the help of the transition table. So where 0, 0 state is relabeled as A, 0, 1 is relabeled as B, 1, 0 is relabeled as C, 1, 1 is relabeled as D. So here in the transition table it was 0, 0, so it is A, because 0, 0 is relabeled as A, 0, 1 is relabeled as B, 1, 0 is relabeled as C, 1, 1 is relabeled as D, A, B, C, D. Next 1, 0 it is relabeled as C, so it is written C. 1, 1 it is relabeled as D, 0, 1 it is B, 0, 0 it is A. Okay, so 0, 1 again it is B. Okay, because it is B here. Next it is 0, 0 it is A, 0, 0 is A, 1, 0 is C. 1, 1 is the last one. The 1, 1 is D, 1, 1 is relabeled as D, 0, 0 A, 0, 0 A, with the outputs same. Okay, so here we have to write the state table for this. So from the state table we need to draw the state diagram. Okay, so how do you draw the state diagram now? How do you draw the state diagram? Whenever it is in the state diagram, how do you draw? I will draw, see here, A. So whenever input is the A, okay, A I have written here, A, with the input 0, 0, it is again going to A, right? So I will write here, with the input 0, 0, it is again going to A. Output is what? 0, 1. Here you have to see. So A slash 0, 1. Okay. So you have to write A slash 0, 1 here. Inside the circle you have to write. Okay. I just tell you once again. Repeat it once again how to draw the state diagram. First you write A with the output here 0, 1. So with the A, input 0, 0, where it is going? A only it is going. So A only it is going with the input 0, 0. Next 0, 1, where it is going? It is going to C. It is going to C with the output 1, 1. C output is 1, 1 here. State C output is 1, 1 here. So with the 0, 1 it is going to C. Next 1, 0 where it is going? Okay. So with the 0, 1 it is going C. With the 1, 0 where it is going? B. B with the output. B is having output 0, 0. So here B is having output 0, 0, 0, 0. Okay, with the input 1, 0. Next A with the 1, 1 it is going D. It is going to D. So D output is 0, 1. Here D output is 0 1. I've written here. So A is going to D. A is going to D with the input 1 1. Okay, D 0 1. Next A is over. A to A when it is 0 0. A to C when it is 0 1. A to B when it is 1 0. A to D when it is 1 1. Okay, next B. So B is going to A. B is going to B when it is 0 0, isn't it? So here B is going to be with the input 0 0. Next B is going to D with the input 0 1. B is going to D with the input 0 1. B is going to A with the input 1 0, 1 0, yes, going to with the input 1 0. B is going to D. B is going to D with the input 1 1. B is going to D with the input 1 1. Okay, fine. Next C state. C is going to C with the input 0 0. So here 0 0. Next C is going to B with the input 0 1. C is going to B. Okay, so C is going to B. This C is going to B with the input 0 1. C is going to A with the input 1 0. C is going to A. Okay, right? C is going to A again with the input 1 1 also. Correct? Yes, correct. C is going to A with input 1 0 1 0. C is going to A with the input 1 1 1 1. Right? So C completed. D with D with the input 0 0 0 0. D with A with the input 0 1. D to A here. D to A with the input 0 1. D to C 1 0. D to C. D to C 1 0. D to A 1 1. D to A 1 1. D to A. So here it is again 1 1. Right? So 0 1. D to A. Here it is 1 no. D to A 1 1. D to A 0 1 and 1 1. Here it is 0 1. Okay, comma 1 1. So this completes the state diagram for this state table. Okay, so here we have A, here we have B, here we have C, here we have D. A has the output 0 1, write it 0 1. B has 0 0, write 0 0. C has 1 1, write 1 1. D has 0 1, write 0 1. So A to A when it is 0 0, so go A to A when it is 0 0. A to C when it is 0 1, so A to C when it is 0 1. A to B when it is 1 0, so A to B when it is 1 0. A to D when it is 1 1. A to D when it is A here, D here, 1 1. Similarly, you complete the state diagram as I have drawn and shown you in this particular example. So this will be the last step for this particular example. So what all did we study in today's class? Given a network diagram, that is logic network, write the excitation and the output expressions. After that, take the characteristic equations and substitute the excitation expressions into the characteristic equations, get the reduced expressions. Those are known as transition equations. After that, we have written a transition table After that, we have written an excitation table. After that, for the transition table, we have written a state table. After the state table, we have written a state diagram. And this is the last step for the